So let's see an example of this. So suppose we're given a function, and we would like to compute the tangent line to that function. So compute the tangent line to the function f of x is equal to e to the 2x at x is equal to 0. Okay, so the graph is going to look something like this. So here's the x-axis, and there is y is equal to 1, and this is y is equal to e to the 2x. So the tangent line is going to touch the graph at this point and just pass through tangentially. Now we know that the slope of the tangent line is equal to f prime of 0 because the derivative gives us the instantaneous rate of change of the function at the point x is equal to 0 in this case. So I'll give you the derivative function. The derivative for this function, f prime of x, is just equal to 2e to the 2x. And again, you'll learn the techniques of how you compute these derivatives, very effortlessly in a little while in our section on techniques of differentiation. But for right now, we'll just treat the derivative as a given. And if you're not given the derivative, you would have to actually compute the instantaneous rate of change by computing the average rate of change over smaller and smaller intervals. So we can do that. We can just pick one small interval for just an example to see if this derivative is indeed correct. So let's compute the average rate of change of f from, let's say, 0 to 0.0001. It's a nice small interval. Okay, well that's going to be f of 0.0001 minus f of 0 over 0.0001 minus 0. Well, f of 0.0001 is 1.00020002 minus f of 0 is 1, and then divided by 0.0001. And the answer is 2.0002. It's actually approximately correct because there could be additional decimals that I'm not seeing in my calculator. I'm not sure, so I'll just write approximately. So the instantaneous rate of change is approximately 2.0002. If we chose a smaller interval, it will get closer and closer to 2, and you can actually do that, go through that for smaller and smaller intervals. Now up here, we have f prime of x is equal to 2e to the 2x, so f prime of 0 should just equal 2 as we expected. Okay, so how do we, now we know the instantaneous rate of change, in other words, we know the value of the derivative at x is equal to 0. How do we get from that to the tangent line? Well, it's basically a line. So what are our requirements? It's a line. It passes through the point on the graph. So this is the point 0, 1. Right? It passes through the point 0, 1, it's right there. And it passes through with slope equal to the value of the derivative at x is equal to 0. So with slope equal to 2. So we can simply use the point slope formula. So the point slope formula is y minus y naught equals m times x minus x naught. So y minus 1 is equal to 2 times x minus 0. So y minus 1 is equal to 2x, y is equal to 1 plus 2x. And that is the equation of the tangent line. Now I encourage you to, on your graphing calculator, or if you have access to software such as MATLAB or Maple, actually make a plot of the function y is equal to 2x. And then on the same graph, plot y is equal to 1 plus 2x. And you'll see that it looks exactly like this picture that I drew for you here today.